Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Whether you need to manage bots, protect cloud applications at runtime, stop form jacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Cyber Risk Alliance, in partnership with InfraGard, has launched the Critical Infrastructure Resilience Benchmark Study. Measure your readiness for ransomware by completing the survey and getting your score. Take the survey at securityweekly.com/CIRB. Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. We are excited to announce our first round of speakers, including Dave Kennedy, Alyssa Miller, O'Shea Bowens, Marina Savata, Patrick Coble, Chris Ang, Eric Escobar, Kevin Johnson, and Justin Kohler. Come join and check it out. And in the meantime, we have a lot of news to cover. This, as I mentioned in the intro, it was summer camp for a lot of you who ventured out into the desert. Black Hat, B-Sides Las Vegas, which was fully virtual, and DEF CON, of course. We will be hitting, I think, a couple, especially the AppSec Village, over the next couple weeks, because there was, I think, so much to cover there, John. It was definitely overwhelming for me to try to keep up with everything, but I think I have at least one article from DEF CON to call out, as well as you saw a couple things as well. In fact, I think you and I, our minds were thinking alike on some of the articles.
Yeah, so we talked briefly over the weekend, like, hey, should we try and make this show all about DEF CON today? And there's just, for two of us, even if we split it in half, I don't think we could have gone through all of it in today's show. So that'll give us some juicy stuff to talk about our next few weeks.
Definitely some juicy stuff. And speaking of timing, where we sort of have an off by one, where there were two articles real quickly that I wanted to get into first. It would have been great tie-in with our episode last week when we talked with Maggie, because they are hardware hacking. The first one was bypassing authentication on a router. And now this is mostly, I'd say, probably not a router that many people have, but the router itself isn't as interesting as how the article says, here is how to connect to the UART. Here's how to get basically a serial shell over a serial connection. Here's some tooling to use, JTagulator, and there are links to all these in the article. So I come check out our show notes, check out the article. But it was a really neat combination of, here is the process to do the physical connecting of wires, hooking up with the hardware. And then once you're inside, the researcher found one of my favorite vulns, .. And not only was this a great path traversal, but it was pointing out one of the dangers of using regexes or misusing regexes, as just in our last segment as well, Tom was warning us about. Because in this case, there was a bypass check that was just doing string matching. So actually the most basic of regexes, if you will. But the string matching was basically saying you can, this auth bypass check is going to say, does it have a /images/ in the URL? And if it does, then we'll let it bypass whatever security checks we want to do. But of course, all of you hackers out there thinking, who've been paying attention to .. if you do images/ // you can traverse back up into an interesting page. And this interesting pages in general can do things like leak credentials, drop your Etsy password if you have old school unshadow password files, or of course get into other types of binaries or other configurations, etc. But really cool write-up, really neat tie-in with our conversation with Maggie. So check out episode 160 as well as this article. And then real quick, John, wanted to draw your attention to more random number generators also on IoT devices. And here again, too, it's a great write-up about some good cryptographically secure random number generators, some analysis of what they need, and definitely getting into a little bit more of the compiled C++ language, C language, if you will, but pointing out that if you're relying on these software libraries, and those software libraries are relying on a hardware abstraction layer that hasn't implemented a good RNG, lots of things can go poorly. And some of those categories of things that can go poorly are generating RSA keys, if you will. And I think generating, looking at weak RSA keys was one of the topics in AppSec Village. So I'm just going to throw that out there as a teaser for us to get into a deeper dive sometime in the future episode.
So those are both really fun articles after last week. I know we want to rip through these, but two comments. First, on the first one of the things to try to cover with Maggie last week is how do we get more people into hardware hacking? What's that first way in? We all have spare routers or routers that we don't use anymore laying around the house. They're all using a pretty basic design on them. The SPI pins or the UARTs or these type of things are usually exposed, and if not documented on the internet, they're silk screened on the board. It's a great way to start playing with this stuff, guys. They usually have vulnerabilities, and they're not that expensive, and if you break it, you don't care. So if you're looking for something to play with, you probably got something in the house. On the random number generator, I saw a different article on it, or at least had a different take than what you just were talking about, which was my interpretation of that was based off of the problem. The reason why this is actually a problem in these IoT devices is there's not an operating system, which we're used to having like Linux or modern operating system, which runs dev random and actually keeps track of how much entropy you have there. So I thought that was sort of interesting that, by removing the OS, which we usually talk about being a secure thing, we're actually causing that issue there.
No, that's a great point. And plus, if they had a great pun in the article title, so couldn't resist that. They did actually present that research at DEF CON 29, so that was good. And some other research that came out of this last week's Black Hat was HTTP 2 flaws. Now, I admit that initially I just wanted to shake my head and say, no, not doing this. We just heard this before. Why do we have to talk about request smuggling once again? But I resisted my editorial first feeling and read through what the deal was. And what Portswigger is pointing out is that HTTP 2 was an original recommendation of how to avoid request smuggling problems. When you have impedance mismatches, if you will, between content length and transfer encoding values. And HTTP2 doesn't have these problems. Well, what he discovered, in a financially lucrative manner, since he got some great bug bounty results out of this, was that, sure, HTTP2 might be on the front-end servers, but if we're also going to have a callback to our segment with Tom and internal APIs or internal systems, what he discovered was that a lot of those HTTP2 servers were just downgrading to HTTP1 to talk on the back end, and voila, there you have it. You can still have a pretty consequential 20K at least type of bug bounty in these types of step downs from HTTP2 down to HTTP1. So again, great research. And I think, to me, pointing out a little bit of my initial frustration about why do we still have these types of problems. I think, to be fair, is to see that I think one of the problems is that it's really hard to roll out a new protocol, again, across all of your services. So maybe if you're doing it in steps, you have these HTTP2 on the front end because modern browsers talk HTTP2. But your backend microservices may not be universally deployed to be able to communicate that way. And that's unfortunately where problems crop up.
It's a great write-up. I mean, talk about, to steal from Kanye and Jay, writing your curses in cursive. I just add up the amount of bounties that he discovered while writing that. I think it was close to what, $60,000-$70,000, I think.
We've got the wrong gig here. We should be doing.
Yeah, they just from the beginning. I don't think you mentioned in there. He had to literally write his own HTTP2 library to be able to go through and do this work. And at first it sounded like the way he described starting off at the beginning of the article is like, I just wanted to do this to learn. And that's, if you want to learn something, write a HTTP stack from scratch. There's a weekend project. But I think, we say this on here a lot. We tend to find a lot of really good reads, but this is really one of them. I mean, anytime you've got a single article, that's relatively long, where you're seeing 4 or 5 bug bounties as a result of it, and I suspect he's just scratching the surface. That's some pretty good work there for however long. Well, I think it took him about 6 months. And this comes right back to the last segment we had talking about internal APIs, quote unquote internal. And if you're able to do something like this, which I suspect this problem's probably going to go on for another 6 or 10 months, right? Because this is one of those things that's an easy fix because it's so broad. That firewall thing, we can't use that as a crutch, the IP firewall, not alone the WAF. But you gotta, defense in depth. So there's another example of that.
Yeah, and I think too a great example that poking at a problem and really understanding it well clearly is profitable, because who knew that I think it was 8 to 10 months worth of research that went into last year's Black Hat presentation about request smuggling. Also had a great write-up. Now proved quite profitable. So James, if you're out there listening, love to hear what you've been doing about HTTP 3, because that protocol is just about to get its stamp of approval and be finalized. So who knows, request smuggling will live long and prosper. I've definitely got one more vuln to talk about here, and then actually going to switch our segment from just talking about vulns and talking about hardening or fixing vulns, because we do want to try to, speaking of an editorial eye, trying to cover several different aspects of application security. But with that aside, this was another fun one about, do you like to read? I can take over your Kindle with an ebook. And this absolutely goes into another category of a great long read and a good article that's that I think is informative for a couple aspects. One, do you just want to understand some of the architecture and how Kindles work on the inside? The same with the Portswigger article about HTTP2. Do you want to understand a little bit more of just what are the nuances of that protocol? It's just helpful, I think, to understand systems to inform your threat modeling, be able to better think about them. And the reason I'm putting a bit of emphasis on that aspect is that it then does go into a lot of some Java, some C fuzzing, that even if you don't necessarily appreciate or understand or want to get into that low-level details of Java and C, I think the principles behind this are still instructive. And if you do want to get into that, it's really neat to see the thought process of an attacker, of a researcher who says, okay, I'm interested in a Kindle. What do Kindles do? They parse things like PDFs. We know historically that parsers and PDFs, for that matter, have a horrible attack surface in terms of being secure. So why not play around with them? And then here are some ways of setting up a fuzzing utility to have some automation help with that manual testing. So I think there's a great sequence there that's really good to emulate if you want to go to continue that effort and look at some other types of file formats on the Kindle, or if you just want to stop at understanding what the Kindles look like. I think both are great ways to read that article. So I'm not sure if, John, I know there's some silence there because I was hitting a couple different angles, and maybe you're still reading the article, but any other thoughts on that one? A different take, perhaps?
Bless me, Father, for I have sinned. I have not read this article. I think, nothing to add. Really, I think it's everything you talked about is sort of spot on for it. The Kindles as a device, again, a lot of us have these readers around the house. What can you do with them? How can you play with them? So I think they're nice targets. What I'd be curious about to see is go back and look at the article closer. How much is a software stack? In other words, how much affects the Kindle app version of that, which I have on my phone. My interest in Kindle recently has been breaking their DRM, which is doable if you want to copy your apps off there, and I'll leave that as an exercise for the listener.
There we go. Finally, we have homework for the listeners. Well played, Mr. Kinsella. In terms of articles that I'm pretty sure you have read, is a good 50-page plus hardening guide from the NSA and CISA about Kubernetes. And again, I had sort of a initial frustrating reaction to this in the spirit of, wait, we need another 50-plus page hardening guide for another service, even though it's important. I guess two responses. One is just read page 2. It has a nice list of here's what we're recommending. And if you understand Kubernetes, you could probably reverse engineer exactly what they're getting into. But what I would really love is that in the future, say 2022, we see a hardening guide, whether it's Kubernetes or something else, that says use the default configuration, and bam, you're hardened for pretty much like all of what you need. And yes, context can be different, but if your context needs some nuances beyond the default configuration, hopefully you're sophisticated enough to understand that and get in rather than having to tweak it to make it work. So that is my sigh on terms of loving that we have good, well-written documentation, pretty comprehensive, but just why do we need yet more PDFs telling us that we're hardening things that just aren't default hardened?
Yeah. Disclosure, I didn't read it. I looked at page 2. Because everything. So there's. I understand why these things are done, right? Especially since this is NSA, CSA. This was NSA, right? And they're the guys that are. Yeah. So they're the ones that are producing these documents for their organizations to harden internally. The orgs that have literally by mandate have to follow what these orgs say. So I understand that to a degree. I went in a slightly different direction over the weekend when I was ranting about this a little bit on the Twitters, which is same basis where you're coming from there, Mike, about another hardening guide. But my thought is we're spending so much time not just writing these damn things, but also having to read them and interpret them. Those of us who, you poor bastards who do read the 50 pages.
Those of us who did read it, John.
How about we go back and put some of that effort into actually making the product secure in the first place? And that's, again, as you said, the Kate's guys do a great job on the documentation side. I know there's a ton of really great security people over there. We've had them on a show and different shows for Security Weekly. But how can we make things a little bit better still so we don't need the hardening guide in the first place is what I'd love to see.
No, absolutely. And there was a theme of a couple articles that I was pulling together about this idea of hardening and protecting. I'm going to skip over to another one from Twilio. And this was interesting because what stood out to me is that, yes, dependency confusion, it was pretty topical. We covered it a couple episodes ago. It's one of the favorite supply chain bingo card topic of 2021. But what was nice is that Twilio described not just what it was, but what did they do about it. And if we go back to that, the 4 questions or, the questions of threat modeling, what are you building? What could go wrong? What should we do about it? That number 3 is often overlooked or often maybe not discussed as much. And that's why I wanted to shine attention here, is that they explained how they went through and protected their environment against it. But it definitely required not so much a combination of technical work as well as relationship work, because what they did was say all of our internal packages are now going to follow a particular naming convention, and we're actually going to delete all the old packages that don't follow this naming convention. And speaking of hard problems just within computer science, one of the cliche answers is naming things. And people can get pretty particular about naming, and should we use underscores? Should we use dashes, camel case, snake case, all the other cases? And to push an organization into one, and here's the other cliche I'll call on, one naming scheme to bind them all, is a pretty good effort, and that requires a lot of communication skills, relationship skills between an AppSec team and a DevOps team that go well beyond the simple technical controls there. So I wanted to really highlight this as an example of using that collaboration, using that empathy work with your DevOps teams to actually kill an entire vuln class, I think, what I'm going to guess from here, pretty successfully.
Yeah, and they do a pretty good job also. I like how the write-up is pretty much English, Yes. So I think that gives us something for, not just for us to talk about, for the junior listeners, or if you want to share this with other people on your team who might not be like into the bit twiddling. This is sort of, it's approachable. Yeah, it sounds like it's a joke, right? It's funny, as you were saying, that made me think back to Silicon Valley's tabs versus spaces episode. But yeah, this is a huge deal. Like, which one is it? Where did it come from? We've been talking about, where's the tip to our supply chain a good portion of the last year, and then this is sort of another example of it, and how to deal with it, how to keep track of it, and try not to deal with it.
Keep track and try not to deal with. And I think that's the other thing that I'm going to belabor this point. Sorry, listeners. But the idea of getting rid of a vuln class sounds like a fantastic win, because now you can move on and spend your engineering efforts into more interesting problems. You were saying something there, John?
No, I just say hugely.
Oh, okay.
It's such a simple sounding statement, but it's massive, right? It's, if we're able to, we've done it to a degree of cross-site scripting. If we can do more and more of these things, just sort of take out the class, that's a huge win.
It's a huge win, and it's one of the things I think thematically tied into this other article I came across from Google security blog, the Linux kernel security done right. And quite honestly, I think you could read this article, and just say, software security done right, or pick your large, complex software engineering project and read through the article and think, how would you answer some of these questions, or some of the engineering investments it's potentially recommending. And John, you and I have talked about this a little bit as well on the show, and my preference and my love for just refactoring code all the time and basically rewriting the same piece of software over and over in secure and beautiful ways for 12 months while the product manager is asking, why the heck haven't we actually delivered a new feature? Yeah, exactly. So my sins aside, as a theme of the week, there's some interesting questions here. So should we just not bother with certain types of vulns? Are there certain vulns that are below a threshold that we shouldn't worry about, that is just not worth fixing? Or should we actually fix every single CVE that pops up in our code, whether it's found by an automated scanner that Tom is running, or that just the developers are running linters, things like that? Should we hire more engineers to fix the bugs, more engineers for code review, things like that? So I think it definitely asks, I think, more questions, or it just says we need more money, which is easy to say, or we need more people, which is easy to say when you have the amount of money that is sitting in a Google software engineering budget. But I think these are good conversations to have at a strategic level with your AppSec team, with your DevOps team, to figure out, yes, we can have a tool, we can have some engineers, but where are the smart ways to infest those?
Yeah. I think I agree with one of your opening statements there, saying this could be thought of as a think piece for not just kernel security, but AppSec in general. And I say that from a point of view, when I first started seeing this one float around last week, the first thought from me was, Linus isn't going to do this. We're wasting our time. But at the same time, he's run a pretty good ship. I'll leave my comments aside, but he's run a pretty good job with what he's done with the kernel over the last, God, man, 25 years. I think we're seeing some interesting patterns, which I'm going to tie back into this. I think some of the questions they're asking here, and actually sort of coming back to your concept there of, do we spin and fix or do we ship? Right. We're seeing a growing number of projects, I'll say, which are sort of approaching this from a different aspect and sort of taking the rewrite aspect, I guess, if I think about it. When do you need a full desktop OS nowadays? Which is sort of what Linux is in many ways supporting, right? If you think about a lot of problems you have in Linux, the floppy drivers, the USB drivers, the graphics drivers, the sound drivers, all that junk is not needed in the Amazon data center.
Nope. And
I think as a result of that, I've seen, I'm not going to remember names, but I've seen over the last week or two, there's a few new OS distros out there that are like, just get rid of everything, make something nice and clean and light that we need, like, sort of like a microkernel. Alpine Linux is doing that in the way in the container side. Then other guys started copying it, doing Slim Debian and things like that. So I think we're approaching it from different ways. So the question is, do you want to actually go through and fix all these things, or do you learn from the past and sort of start over? And I think that's I think I'd lean towards that, to be honest. I'm not saying it's death to Linux. I think Linux is going to be around for another 20 years. I think while there might be some problems in there, do they need to be fixed? Probably not, in a lot of cases. But there's space for the new, younger, cooler, hipper versions of Linus to come up with something new and different. I think that's what we're going to see.
Yeah, I think there's definitely a future where the curation of Linux could definitely benefit from improvements and embracing a broader community to be forward looking on. Let's actually, you mentioned floppy drivers, like. Sorry, listeners, I know I make a few references to 80s pop culture, and some of you may not even heard of those bands or seen those movies or seen the floppy disks that are in those floppy drivers. Who knows? But I think real quick, there's one article that I wanted to get to, but it's sort of on this theme. One of the aspects that was missing from this article, correctly, was a discussion about, possibly correctly, was a discussion about programming languages. And I think I'm still right now in the camp that most programming languages, except for Perl, can be written securely, can create secure code. And we've seen a move towards memory-safe languages. Seems like a good trend. Golang, Rust. But I will still always harp on the idea that we're still just going to introduce new and different types of vulnerabilities in our memory-safe languages. And you had an example of this. John, tell us about this.
Remind me of my articles. That's not fair. Tell me what I wrote.
IP addresses.
Oh, yes. I'm sorry.
Yes.
Your lead-in was too good. Yeah. I was still stuck on thinking if JavaScript was a secure language. And yeah, so this was, we talked, I don't know, for 8-10 episodes ago, probably about the netmask library on JavaScript, which was parsing octals incorrectly. And we're now seeing more recently, an article came out last week that Golang and Rust were having the same problem. And I think what's interesting about that to me, beside the fact that, there's a pattern we've seen now, and it's okay. The next question is, if you are a language writer or maintainer, what are you going to go and check next? Maybe go and check how you do your IP implementations, right? I think that's sort of the surprise here for me. The fact that it came up in Golang and Rust, and it sounded like the use cases were almost identical, where the misparsing was happening, makes me wonder if there was some borrowing of code, not copyright, but just borrowing of code going on there, and everything associated with that. It's funny, we're hitting a bunch of different themes here. I've been thinking in the back of my head as we talked through before about scanning APIs and things like that, and now some stories like this. As I write new code, how do I test? to make sure I don't have problems like this, right? How do I improve my unit tests, or when do I use fuzzing to actually make sure that, even that previous article you were talking about today about the use case of a malicious user thinking through, okay, well, a Kindle is a parser.
Mm-hmm.
How can I take effects of that? How can I take advantage of that parser or see where the weaknesses are? That gets me a little nervous, as I start taking input from outside sources. So how can I actually make sure that I'm testing to a good enough level? And I think that's an interesting, both the threat model that's related to that, but also the thought experiment around that is where my concern is. The languages will get there. I think this is one of those edge cases which. It'd be interesting if there was actually real-world attacks based off this, which were successful.
Great point, because there are software flaws and then there are exploitable vulnerabilities. So context is important. Still in the camp of fix the bugs, but the exploitability, the potential impact of the vuln can just help influence the priority of the engineering effort needed for that. And as John, I've got one final article here, which I think ties into the spirit of what you were saying, in the sense of, I'm writing my code. How should I test it? How should I think through it? How should I threat model it? And this is an account takeover checklist. And normally, once again, I'm listing all of my editorial pet peeves and frustrations, is that typically, I shy away from top 10 lists, especially ones that have cross-site scripting and SQL injection on them, because I think 20, 30 years of AppSec have kind of demonstrated that just a checklist isn't going to be very helpful. However, in this case, I think this is a pretty good checklist, because it is actually a comprehensive one that is I'll call it a product-oriented checklist, because it talks about account takeover, countering them, how to harden your application against it, and it includes two important aspects. One, the user experience. So it's looking at how is this product built. It's not just talking about very specific things like use MFA, move on, use rate limiting, and you're done. It's talking about what is the product experience for your users? How are account reset flows work? How can different types of scenarios, how can different types of users be targeted, abused, things like that? What information can you deliver to embrace your users as part of the security control, for that matter? And it also very helpfully talks about customer service. When someone is legitimately locked out, has forgotten their account has been taken over, how do you identify this person? How do you walk this person through the steps to get their account back? And so I think that what was really nice about this checklist, again, it went beyond just the technical list of do these 3 or 4 things in your code base, and it adds on to that. Consider these aspects of your product, consider these aspects of the lifetime of your product, the customer service aspect of it. So really stood out in my mind. It's a great checklist, a great read for that. Great reference.
It's a great, it's not a scare tactic, but like a scare piece too. Not a bad way, in a really good way. He's done a really good job at boiling down and condensing the thoughts into his bullets. And hell, man, I get like 3 or 4 bullets in here, and I'm already starting to go, oh, Jesus, how much of this have we actually done? And, I think he's covered a ton of really great material in here that, 4 or 5 words make you start go, okay, there's the rest of my day. Well, just tracking down that one. But at the same time, he does it, as you're saying, both the customer service and response point of view, which I think is really handy. And apologies for our U.S. government listeners. I think he probably did this on purpose. ATO, the acronym he's using, is also used for what I believe that's attestation for bringing new systems online that have clearance, if I remember right.
Ooh,
could be wrong, but
not sure about that one. There we go. I've got homework for this episode to go double check that acronym. But with that, I think we're coming to a close. We've hit our time limit. I do want to have one last comment though. And speaking of movies, did you know that the 80s horror movie American Werewolf in London came out in August 1981? Do you like puns like IoT? You're doing IoT wrong? Well, if you want to like and subscribe, for you horror fan, werewolf listener, pun-loving listeners out there, like and subscribe our Application Security Weekly. And with that, I want to say thank you for joining us. I want to thank John before he starts groaning, and we'll see you all next week. Applications.